Welcome to today's Explainer. If you're a web developer looking to make the leap into mobile app development, you are in the exact right place. Consider me your enthusiastic mentor for this session. We're going to completely bridge the gap between the web development concepts you already know and love and the powerful, truly native world of mobile using React Native. We'll take those familiar web ideas, translate them into mobile concepts, and even learn exactly how to ship the final product.
Okay, let's dive straight into this. Here's our roadmap. First, we'll cover the shift from web to mobile, then building your native interface, followed by designing for all users. After that, we're shifting gears into DevOps with Expo application services setup, shipping with EAS Build, and finally wrapping up with EAS Update and manual channels.
Starting with Section 1, from web to mobile, it's all about that initial mindset shift.
So, leaving the web browser behind requires a pretty fundamental change in how you think. On the web, you're totally used to structuring things with div tags, dropping text into p tags, and basically just praying your CSS flexbox centers perfectly, right? Well, in React Native, we use what are called core components. Your trusty div, that becomes a view, which is essentially just a non-scrolling container that natively supports flexbox layout. Your p tag simply becomes a text component. It's a really direct conceptual translation, but under the hood, something so much more powerful is actually happening.
And this brilliantly illustrates why React Native is such a game changer. When you write a view or a text component, you aren't just rendering some clunky web page inside a mobile app wrapper. Not at all. At runtime, React Native actually compiles your JavaScript components down into true, highly performant native platform UI. For example, on Android, your view literally becomes a native view group, and on iOS, it becomes a UView. Same goes for your text component. It translates directly into an Android text view or an iOS UI text view. So you're writing in React, but your users are getting a 100% authentic native experience.
Moving right along to Section 2, building your native interface.
Now that we've got our building blocks, let's actually arrange them. To build out your UI, you'll be using that familiar Flexbox layout system. And to keep your apps look totally consistent and reusable, you'll use the style sheet abstraction layer. You can think of this as React Native's answer to CSS classes. Now, what happens when things don't look quite right? Well, because you'll be using Expo development builds, you actually get access to the React Native Inspector. It's an awesome tool that lets you visually inspect native elements and debug layout errors right there on your physical device.
But here's a real challenge for you as you make this move to mobile. Think about a standard scrolling feed, like a social media app. What happens when your list has 1,000 items or 10,000 items? On the web, the browser's DOM can sometimes power through massive lists if you're lucky, but mobile devices have incredibly strict memory limits.
Well, React Native has a completely brilliant way of solving this exact performance bottleneck. Let's look at the basic scroll view first. It's a fantastic generic scrolling container, sure, but it renders absolutely all of its children at once. If you try to shove 1,000 items into a scroll view, your app is almost definitely going to crash from running out of memory. So, what's the fix? That would be the highly performant choices, flat list and section list. These components are incredibly smart because they only render the elements that are actively showing on the user's screen. As the user scrolls down, the components that disappear off the top are removed from memory, and the new ones coming up are rendered just in time. It is super efficient.
To really polish up your native interface, you're going to want to leverage a few specific APIs. For instance, the Pixel Ratio API gives you direct access to the device's pixel density. This lets you perfectly crisp up your image assets depending on the specific phone hardware you're running on. And hey, when you need to actually fetch data for that massive flat list we just talked about, you can just drop in an activity indicator. It's a core component that automatically handles rendering the exact right platform-appropriate circular loading spinner.
All right, Section 3. Designing for all users. Building a great app fundamentally means building an inclusive app, right? Thankfully, React Native provides a deeply integrated tool for this called the Accessibility Info API. This API is specifically designed to query the current active state of a device's screen reader, like VoiceOver if they're on an iPhone or TalkBack on Android. It also lets you register listeners for accessibility changes. This gives you the ultimate power to dynamically adapt your UI to meet your users' specific, real-world needs.
So, practically speaking, how are we using this? The API offers some really straightforward methods, like is screen reader enabled? You can literally just check this state, and if it comes back true, maybe you dynamically simplify your UI layout to make swiping through elements a bit easier. Another incredibly empathetic tool you have is Announce for accessibility.
Say an important status changes on the screen, like a background file download finally completes, you can pass a string directly to this method, and the screen reader will speak it out loud, ensuring visually impaired users absolutely do not miss that critical context.
Now here's a quick pro tip. You always have to remember that Android and iOS are entirely different operating systems, meaning they have entirely unique accessibility features. The Accessibility Info API gives you some very platform-specific methods to handle this. For example, Android has the is high text contrast enabled method, while iOS relies on is darker systems contrast enabled. By checking these specific flags in your code, you can natively support high contrast modes dynamically, just tweaking your style sheet values on the fly to ensure perfect readability on either platform.
Let's move to Section 4, Expo Application Services Setup. All right, so you've built this beautiful, native, accessible interface, but how do we actually get it onto a user's phone? This is where DevOps and Expo Application Services, or EAS, step in. The setup is incredibly straightforward right from your terminal. Step 1, you just install the CLI globally using npm install-global EAS CLI. Step 2, authenticate by typing EAS login. And Step 3, connect your local project to the cloud services by running EAS Build configure. It's really that simple.
Which brings us to Section 5, Shipping with EAS Build.
With our configuration perfectly set up, we're ready for the heavy lifting. There are two primary services you'll use here, and it's absolutely crucial to understand the difference between them. EAS Build is your heavy lifter. It takes your code, compiles it in the cloud, and spits out the heavy binary files. You know, the APK for Android or the IPA for iOS, which you need for a full App Store submission. EAS Update, on the other hand, is a whole different beast. It allows you to push over-the-air JavaScript and asset changes directly to your users' devices. This updates the app incredibly fast, without ever requiring them to download a new version from the App Store.
Finally, Section 6, EAS Update and Manual Channels.
Now, while EAS Build and EAS Update work beautifully together, some development teams actually prefer using their own custom CI/CD pipelines, and they only use EAS Update for those slick over-the-air patches. But if you do choose to decouple them, you need to know the trade-offs. First off, you lose all the automated bookkeeping on the expo.dev dashboard. You also lose the automatic runtime version guidance. And most importantly, because EAS Build isn't there to inject your update channels at compile time, you are going to have to manage your release channels entirely manually.
To actually handle this manual setup, you'll need to configure the update channel yourself by setting the request header directly in your app config file. After that, you have to literally tell the Expo servers that this specific channel exists. You do that by running a simple command in your terminal, like ES channel create production. Honestly, it's a bit more hands-on, sure, but it gives you ultimate flexibility if your company mandates a really specific, non-Expo build pipeline.
And there you have it, we made it. We've journeyed all the way from mapping simple web HTML to React Native core components, optimizing our interfaces with flat lists, injecting real empathy into our apps via accessibility APIs, and finally, setting up a proper EAS DevOps pipeline. The gap between web and mobile? It's really not a chasm anymore, it's just a bridge waiting to be crossed. So I'll leave you with this one thought. Now that you hold the exact same tools used to build some of the very top apps in the world, what incredible mobile experience are you going to compile and ship first? Thanks so much for joining me for this explainer, and happy coding.